All right, so securing mobile devices. Well, that's going to be a pain because everybody has these mobile devices. Everybody wants to use them. Everybody wants to be able to do fun stuff at work and perhaps reply to some work email when at home. And it's going to be a pain because there's just so little inherent control to these devices. They could be anywhere, that could be used for any purpose, and everybody has them. And they're also pretty powerful. So let's see what solutions we have for securing mobile devices. So let's start by discussing the generic methods by which these mobile devices end up in the possession of your employees, of your users. Starting with the latest, not so latest actually, but more recent trend here of bring your own device to work. That's basically a deployment model in which the users are allowed to choose their own device, to buy their own device, and to bring it into the workplace for business-related tasks as well. Now, of course, if you plan on using this, you will need some sort of oversight of some sort of high-level management ability for these devices, because otherwise you're just inviting all types of operating systems and all types of malware and apps and whatnot into your network, and that's probably something you don't want. Even more than that, your users, your BYOD users, will have to submit to some sort of security policy, a mobile device security policy that you should have implemented in your company. They might be required to accept the fact that you will need to install some apps onto their devices, onto their mobile phones and tablets, and that some of their actions, especially those work-related, or hopefully only those work-related actions, are going to be monitored by some centralized monitoring software. Not everybody might agree to this, so bring your own device might not be the best solution for a company. The more traditional method is COBO, that's corporate-owned, business only. You are given a work phone and you can use it for work-related tasks only. In that situation, the work phone is most likely hardened and locked down by the IT department, so you're not allowed to install your desired applications. In case it can be used for personal purposes, such as browsing the web just by using the embedded browser, you're probably discouraged to do so by the acceptable use policy or the internal set of rules of the company. A more relaxed approach to this is COPE, corporate-owned, personally enabled. It's still a business phone, but you are allowed to browse the web, log into Facebook, maybe chat with your friends on the same phone, of course, subjected to the company security policy. And an even more relaxed alternative to this is CYOD, choose your own device, where the employees are given multiple options to choose a phone among these options, but the phone is still going to be owned by the company, hardened by the same security policies. It's just that you perhaps prefer Android, not iOS, but that's pretty much it. That's pretty much the level of decision that it's expected of you. I've added here as a special mention for VDI, Virtual Desktop Infrastructure. Virtual Desktop Infrastructure is a type of deployment. It's not exactly mobile, but it can be. It's a deployment in which, instead of providing your employees with physical workstations like laptops and desktops, you're providing them with virtual machines running in some data center. It might be local to you, it might be in some cloud perhaps. Those employees, those users, only need to connect over some sort of a remote desktop connection to that virtual machine in the data center. Now, there are benefits to this and there are downsides to this. First of all, in order for them to be able to connect that virtual machine, they're still going to need some sort of device, right? You're going to need something to plug their keyboard and mouse into, and perhaps it would be nice to have a display, right? For VDI environments, we have something called a thin client or a thick client, depending on how much hardware, how much resources they have. Thin clients, for example, are just very, very simple. I wouldn't even call them computers. They're just a small box with a network interface and some USB ports that can only do one thing. They can connect over the network to that virtual machine in the data center, and that's it. Now, that virtual machine in the data center can also be accessed, for example, from home. You can remote desktop from your home computer into the same virtual machine that you use when you're in the office, and you get the same user experience, you get access to the same type of data, and you're also running it in a controlled and isolated and secured environment. From a management perspective, this is heaven, because management and security perspective, because you keep a tight hand, a tight control over all the workstations of your employees. If you need to patch something up, you can just do it automatically overnight. You don't need to wait for those employees to come in to log into the network and push an update to them. If you need to re-image one of those virtual machines, perhaps because somebody has downloaded a virus, right, a malware, you can easily just rebuild that virtual machine in a matter of minutes or even seconds. So from a management perspective, it's great. From a user perspective, it's great-ish because they're going to have some latency, they're going to have some delay, and they also are going to be experiencing a highly controlled work environment. They don't really have that much flexibility in working with that virtual desktop. Now, unfortunately, if you run all your desktops in one single place, in one single data center, that's kind of becomes a single point of failure. Or if it's not a data center that fails, it might be your internet connection that fails, right? If you suddenly lose internet connection in a traditional workspace, well, people just are going to stop browsing Facebook, right? But they might still be able to do their job. But if their desktops are located across an internet connection, well, you're going to have a bad time. Everybody is going to go home and your business is going to come to a halt. So pros and cons for VDI, depending on your environment, depending on the types of users you have, it might be a good choice for your company. So what are the solutions available for controlling a bunch of mobile devices that belong to the users, to the company, or somewhere in between in an enterprise network? We start with mobile device management. These are simple solutions that deal with controlling how that specific device, that specific mobile device, can be used. For example, we can enable that only devices that have a PIN or a fingerprint reader enabled or a Face ID security measure enabled. We can even disable, let's say, the camera and the microphone for those devices so that people are not going to exfiltrate any data using that mobile device. And we can even perform remote wipes on those devices in case they get stolen or compromised in another way. Another type of solution here, just like the name says, it's application management, mobile application management. It's about deciding what applications can the users run or install and run onto their mobile devices. Now, it's not just about application because in most cases this can be easily implemented by a custom app store or a Play Store. Most vendors out there support the ability of a company, whenever that device becomes managed by the IT department of that company, to push only a specific subset of applications from the official app store. Right, so you're only restricted to the company apps or the apps that the company has deemed adequate for you to use in the workplace. Even more than that, we need to take care of the data. So it's not just the applications, but what data they're processing. So you might be able to access both your business email and your personal Gmail account, but are you able to share a file from a business email and attach it to a personal email in another app? That's why most solutions that deal with mobile application management implement some sort of a containerization inside of the mobile device. It's not about Docker containers, not those type of containers, but it's a type of storage isolation so that business applications have their own storage space and personal applications have their own storage space. And more often than not, things don't jump the fence. And finally, we have more complex solutions called unified endpoint management. Notice it's not just about mobile here, it's unified endpoint, anything that's an endpoint. So these are solutions that can extend, patch management, policy management, access control, down to each and every type of device that your users might use to connect to the network, not just their mobile phones and tablets and wearables, but even their desktops, even their company laptops, and even the access to peripherals that those devices can access. So that's unified endpoint management. Think about it as anything can be an endpoint, so that's one solution to rule them all. Nobody should be surprised nowadays that we only get a choice between two major operating system vendors as far as mobile devices go, and those are the Android operating system and the Apple iOS operating system. Now, first of all, they both support enterprise management solutions. So regardless of what operating system you're using, you can centrally control it. You can push your policies. You can push a custom app store. You can wrap your business applications however you see fit. So they do offer pretty much the same level of flexibility. Now with iOS, you do get a more locked down system. That is, not any application can reach the App Store. They're more thoroughly tested. And by its construction, by its design, Apple iOS doesn't really allow your applications to perform that many malicious operations outside of their internal container, outside of their sandbox, so to say. Which is great news from a security perspective, because it's rare to hear about the type of malware that infects iPhones. That's simply because there's so much isolation within the operating system itself and between the applications in that OS. Android, on the other hand, is much more relaxed when it comes to applications. It's much easier to push custom app stores to Android, and it's extremely easy to install separate applications from their APK files, so you don't even need to go through an app store. It does offer more flexibility, but also it exposes a larger attack surface. And there's also a very significant difference when it comes to operating system updates. Well, with Apple, everything is controlled by Apple and the updates are pushed immediately to all their phones, all the devices. With Android, you're going to have to wait for the specific vendor of that phone, of that brand, to release an update or to wrap that update that was originally released for the Android kernel and make it compatible with that specific handheld or with that specific version that you're currently holding. Which obviously means that you're going to have to wait some more, and updates are not going to be so frequent, and when they do come in, you might have to wait a couple more days, sometimes weeks, sometimes months, before a specific major, minor, or even a patch version for the Android operating system is implemented by your chosen vendor where you just bought your phone from. One of the basic settings in pretty much any mobile device management solution out there is going to be the fact that we're only going to allow devices to connect to the network if they have some sort of an authentication system enabled, so that we can filter out foreign users of those devices. So for example, for a smartphone, we might ask to have at least a PIN enabled, if not, fingerprint recognition, Face ID, or any other methods of authentication. A screen lock is also mandatory in most cases, especially in default policies. That is, whenever the phone is turned off or times out and the screen turns off, it is automatically going to require re-authentication on the next use. You can even go a step further into implementing these security policies by looking at the context of the authentication. So for example, you could allow your users, if they are at home, to bypass some of these requirements. So for example, disable the screen lock if they're at home in a safe environment. Or we could be looking at what type of internet connection that device is currently using. Is it using a public Wi-Fi, or is it using a 4G or 5G connection to connect with our company? So we might want to enable specific features depending on the context and the location of the device and of its user. Remote wiping devices is another feature that is strongly desired by all companies that use mobile device management software, and that is the ability for the company to remotely send a command to destroy all the data in that device. You can probably guess that this is very useful whenever the device has been stolen, so that the data inside of it, the emails, the files, the cached passwords perhaps that the user might have had stored in there don't become public knowledge, don't end up in the possession of the thief or of the attacker. Now, pretty much all mobile devices nowadays enable full disk encryption. Well, if it's not exactly a disk, it's going to be called full device encryption, right? But all the contents, all the flash stored contents in your mobile phone are most likely completely 100% encrypted. Now, this encryption also happens using a key which is stored on the device itself. And access to that key is protected by the screen lock, by your Face ID, by your fingerprint, and so on. Now, this also means that whenever a remote wipe command is being sent to the stolen device, it actually doesn't need to delete all the data on the device. It only needs to delete the encryption key. We can leave the entire, 2 terabyte iPhone completely populated with data in the hands of the attacker because we know that it doesn't have the necessary key to decrypt that data. It's gibberish, and it will always be gibberish for that attacker. So remote wipe is actually just a small command that deletes a very short string, which is the encryption key. With iOS, you get full device encryption automatically. With Android, at least in Android 10, you don't really get full device encryption because it kind of stresses out the CPU a lot, and not many Android devices are really powerful. But you do get file level encryption. So your files are encrypted, it's not the entire storage space. Also, on Android devices, some of them still support external SD cards. You have to be careful whether those SD cards are also encrypted by default or not, because many situations they're not. And yes, even with mobile devices, there is a functionality that can mimic the behavior of a TPM, but it can also be removed. And that is a microSD HSM hardware security module, which can be attached to the mobile device, and it has pretty much the same use cases and same purpose as a TPM, that is storing cryptographic data, with the additional benefit of being able to remove it and attach it to a different device. Mobile devices are extremely location aware nowadays, as you probably know. So as part of the mobile device management security policies, you could also enable some policies that refer to how the location services in your phone work. Now, you do have GPS, of course, global positioning system. You also have indoor positioning system, which can be reliant on Bluetooth low energy beacons, for example. I must say that the acronym IPS, meaning indoor positioning system, is an extremely bad one, because I can bet that you're not thinking about indoor positioning when you're hearing IPS. Nevertheless, additional security functionality based on location can be enabled for geofencing, for example. Geofencing means creating some sort of a virtual boundary that matches to some real-world location, and whenever you step inside of that virtual boundary, a specific type of policy starts applying to you. So for example, you could have your company-owned devices to automatically disable their cameras whenever the phone is detected inside of the building. Right, so the phone detects its location and automatically disables a hardware component so that it cannot be used to exfiltrate data. Finally, you might want to disable these location services also because most phones tag specific events and photos with location information. So they store the location where the photo was taken inside of that photo. Now, these photos, when uploaded to centralized storage or to some cloud environment or to social media, might be used to track a person's movement or the person's history, which brings up a whole bunch of potentially legal issues. As for managing the applications on your phone, the most widely used approach for a company to implement their security policies as far as their mobile devices go is to implement a whitelist approach. That is, this is the list of applications that you're allowed to install, and that's it. We're not going to approach this on a blacklist approach because it's pretty difficult to figure out what are all the possible applications out there, especially since there are hundreds of thousands of new applications emerging every day. So it's much easier to check just a bunch of pre-validated, pre-checked applications, include those in a custom list or a custom app store, and then allow your users to use only those applications. Careful with Android, because Android does have the ability to load applications from other sources, other app stores, or even directly from APK files. Now, even with iOS devices, you can still load applications from custom app stores, but this requires jailbreaking the phone and identifying inside of your mobile device management policy a jailbroken phone should be a no-no from the start. That is, if you detect a jailbroken phone in your network, don't allow it network access by any means, because a jailbroken phone is basically a phone where your security policies mean nothing. If the operating system is compromised or is under the user's control, whatever you choose to install on top of it, every mobile device management software or every containerization solution you might have in there, it's useless because the user can easily circumvent it. So just as we mentioned before, make sure that whenever you're managing application policies, you're also managing data policies. That is, try to keep the personal data separate from the business data. Most mobile management solutions can do this for you automatically, but some policy in there is required, especially DLP policies that try to detect whenever data tries to migrate from the personal area to the business area and vice versa. And as part of your mobile device management security policies, as I said before, you're not going to want to allow any rooted or jailbroken devices. By definition, rooting applies to Android and jailbreaking applies to iOS devices, but that's just a convention. It basically means the same thing, is providing the user of that device with root privileges or full privileges, allowing the user to do virtually anything with that device. A carrier unlock is a lighter method of tampering with a phone that is removing the restrictions for a specific wireless carrier. You might want to allow this since it doesn't really pose any serious security risks in your company. And also don't forget that your mobile devices are a gateway, basically, to the internet, to your local networks, to remote applications, and they need network connectivity to do this. And they have a bunch of interfaces, actually, starting with the cellular connectivity. Make sure you're aware of the fact that no matter where the user is located, they will have cellular connectivity, unless you actually want to disable this altogether. Of course, all devices have Wi-Fi, they all have GPS, and you get to choose whether you're going to leave that functionality on or off. Personal area networks are basically Bluetooth connections. If your users don't require specific Bluetooth peripherals, especially when they're within the company premises, you might want to disable Bluetooth because a lot of malicious devices can connect over that network interface. Ad hoc Wi-Fi and Wi-Fi Direct. This is the ability of a mobile device to create a small point-to-point connection with another device. Think about this one whenever you're designing your DLP policies, for example. You might encounter situations where data is exfiltrated over an ad hoc Wi-Fi connection simply because it never reaches your company firewall. And also think whether you're going to allow hotspots or Wi-Fi tethering between your mobile phones and your company workstations. Because you might have your workstation thoroughly hardened and all the traffic that goes in and out of that workstation is analyzed and for intrusion prevention and decrypted and goes through a firewall and whatnot. But what if somebody simply connects their phone to that desktop or that laptop and that host suddenly starts communicating directly over the cellular connection of that phone without going through any of your company security filters? How bad is that? Bluetooth is still a very common standard among many mobile devices and accessories. And you might be thinking that, okay, Bluetooth can be used for pairing, headphones and peripheral devices and whatnot. It's probably not the best way to exfiltrate data. Well, think again. Many implementations actually use Bluetooth to create a pairing connection with another device and then create an ad hoc Wi-Fi connection to transfer actual data. This is how AirDrop works on your iPhone. And of course, there is malware that targets devices over their Bluetooth connections. Remember just two. For the exam here, we have bluejacking. Bluejacking is about receiving unsolicited data over a Bluetooth connection, especially those Bluetooth connections that don't require any sort of authentication or PIN to send data. So unsolicited texts, images, contact cards, and so on. That's bluejacking. While blue snarfing used to be, not anymore, especially for newer devices, it was an attack that allowed an attacker to extract data without the victim's knowledge from their mobile device over Bluetooth. And don't forget about the fact that very few phones nowadays still have infrared connectivity. Now, we actually have two types of infrared, one of them less common than the other. The one that's less common is the infrared blaster functionality. That is when you can use your phone as a remote control. That's not so common anymore, but we still have infrared sensors on our phones. For example, whenever you hold your phone next to your ear, the screen dims down. That is because there's an infrared sensor in there that senses the fact that the phone is being held close to your face, to your ear. Other types of communication methods are RFID, which are based on some passive tags that when powered by an electromagnetic field, they can return back some sort of data. It's very useful for inventory management, for anti-theft solutions. A common attack here is called skimming, which relies on the use of a fraudulent reader to extract the information from these tags or from contactless credit cards, for example. Keep in mind that there's no authentication built into RFID, so whoever has access to that tag can immediately read the information from it. NFC, or Near Field Communication, is a specific type or specific implementation of RFID, and this is one functionality that is now built into most smartphones and even smartwatches. It can be used for pairing devices, it can be used for contactless payments. There are a lot of use cases for NFC. It can also be used to read passive tags. So the classic RFID tags can be used by an NFC antenna in your mobile phone. Unfortunately, there's no encryption built into it. So the NFC signal can be intercepted and read by pretty much anyone, even though the range is really, really small. Now you might be thinking, so contactless payments are not secure. Well, they actually are, because no credit card data is actually sent over NFC, just a one-time token that is validated by the bank. So even if that information is skimmed by a malicious attacker, the fraudulent transaction can be easily flagged and easily detected. So your contactless payments are pretty much safe, for now at least. Also, don't forget that when it comes to mobile devices, the actual charging port is also a data port. So attaching an external storage device, such as an OTG device or OTG cable with some mass storage drive or mass storage device at the end of it, can enable that smartphone to communicate with that mass storage device. Well, if the device stores malware, then the phone can be infected as well. There is also the remote possibility, even though proven to exist, of a charger to be maliciously infected with malware. That is a charger cable, which you just plug into the wall socket. It's actually more than just a charger cable. It's actually presenting itself as some sort of a mass storage device. You don't know about this, but when you plug it into your phone, the charger actually starts attacking your phone. And that's why it's called juice jacking, by the way. And even though you might not be using these anymore, your phone still supports SMS and MMS messages. Now, the vulnerabilities in these services stem from the fact that they rely on the same cellular communication method that has been around for quite some time. That is SS7 encoding and encryption. Now, there are studies that can show the fact that these messages can be intercepted, which is why some security vendors prefer not to use an SMS message as an out-of-band verification for two-factor authentication method. Another one that you might not have heard about is RCS. This one stands for Rich Communication Services, which is one way of implementing something similar to iMessage or Telegram or WhatsApp into the native functionality offered by the carrier, the messaging functionality offered by the carrier. If you haven't heard about it, it's probably because nobody uses it. There really isn't that much support from the carriers either. Push notifications on a mobile phone can also present a risk because they might be generated by malware. They might trick the user into thinking that a notification has been generated by a legitimate app. They just tap on the notification. They might be required to enter some authentication details, and there you go. Those details actually end up in the hands of an attacker. Firmware updates are completely different from OS updates and app updates, and they happen most of the time without you even knowing on your mobile device. These are sent over the air, so it's an OTA update that updates the driver in your radio, in your cellular radio, updates the real-time processing operations in your data encoding and decoding that happens in the background, apart from whatever you see on the screen related to the operating system and your apps. So it's basically one way of updating the low-level functionality, radio functionality of your phone. This happens automatically because it is driven by the carrier, so the carrier takes care to update from time to time all its clients that connect to its cell towers. Unfortunately, you don't really have any say in this. Apart from situations where you're running a jailbroken or rooted phone, where you might be able to filter out these updates, you don't really have any control over them. And there have been exploits, there have been demonstrated exploits of fake base stations imitating cell towers that are able to push malicious updates over the air to user phones without any interaction from them, or even without them knowing that the update is happening. Finally, one last method of communication is based on microwave links, and it has nothing to do with microwave oven, but the microwave link is sometimes provided as dedicated connection between a remotely accessible cell tower somewhere in the middle of a field or of a desert and back to the main network of the operator. It also can be used to provide network connectivity in the remote areas. You have point-to-point connections or you have point-to-multipoint connections over microwave. And these types of connections are sometimes used temporarily as well. So for example, for hosting an event or a concert with a large number of participants somewhere in the middle of a forest or in the middle of nature, and you want to provide high-speed, high bandwidth communication to that location, you can add a microwave link. That was a lot, so I feel the need for a break, don't you? So during the break, don't forget to like and subscribe, leave a comment if you wish, support the channel if you can, and see you in the next video. Thank you and bye-bye.